Hello everyone, 146 branch 82 L2 gamma S equals sigma plus I tau gamma S equals integral 0 to infinity t at s minus 1 times e at minus t dt is holomorphic in sigma greater than 0. And proof: gamma x equals integral 0 to infinity t at x minus 1 times e at minus t dt. This is definition. And the epsilon is positive, t is positive, t at x minus 1 times e at minus t is more than t at x minus 1. Okay, point A. And integral epsilon to 1 t at x minus 1 times e at minus t dt is small than integral epsilon to 1 t at x minus 1 dt from A. Okay. And calculate equal 1 over x minus ex over x, and this value is negative, then integral epsilon to 1 t at x minus 1 times e at minus t dt is more than 1 over x. X is positive. And x fixed epsilon is positive, this integral has monotonous increase in sums and upper bound. Circle A, circle B. Integral epsilon to 1 t at x minus 1 times e at minus t dt epsilon close to 0 as uniform convergence from circle A, circle B. And x is positive. Point B. And next, E at t is expansion, and E at t is greater than t at n over n factorial. This is sums. T is positive. Point C. X fixed n greater than x plus 1, n is natural number. T at x minus 1 times e at minus t as small than t at x minus 1 times n factorial over t at n. This is from C. E at minus t, and this term left side, this is, and equal n factorial over t at n plus 1 minus x. T is 40. And then integral 1 to u t at x minus 1 times e at minus t dt is small than integral 1 to u n factorial t over t at n plus 1 minus x dt from this inequality then, and calculate equal n factorial over n minus x times 1 minus 1 over u at n minus x. And this value is more than n factorial over n minus x. This value is negative then. And this integral has monotonous increase sums and upper bound. And then integral 1 to u t at x minus 1 times e at minus t dt and close to infinity is uniform convergence from C and D, circle C, circle D. And x is positive, point D. And from BD, gamma x equals integral 0 to infinity t at x minus 1 times e at minus t dt is uniform convergence in x is positive from B and D, interval 0 to infinity, uniform convergence. Okay. And del sigma 0, sigma 1, this is, and this is point E, and integral 0 to 1 absolute t at s minus 1 e times e at minus t dt equal s equal sigma plus I tau, then, and equal integral 0 to 1 t at the sigma minus 1 times e at minus t dt. And this value is small or equal 0 to 1, integral 0 to 1 t at the sigma 0 minus 1 times e at minus t dt. T at x function is this interval discrete then, and this value is small or equal interval 0 to 1, 0 to sigma, 0 to infinity, okay, and equal gamma sigma 0. And integral 1 to infinity absolute phi at s minus 1 times e at minus t dt equal integral 1 to infinity t at sigma minus 1 times e at minus t equal, and this value is small or equal integral 1 to infinity t at sigma 1 minus 1 times e at minus t dt. T at x function is increase function, this interval, okay, and this value is small or equal 1 infinity and interval 0 to infinity. This is small or equal, and this is gamma sigma 1, okay, and point F. And large n1, large n2, this is, and absolute integral 0 to n1 t at s minus 1 times e at minus t dt as small or equal up to t at s minus 1 times e at minus t. Okay. And equal t at sigma minus 1. S equals sigma plus I tau. And this value is small or equal t at sigma 0. Okay. Sigma 0. This interval t at x function is a discrete function. And integral 1 to n2 t at s minus 1 e at minus t dt absolute equal or small or equal this is, and this is, and sigma 1, and t at x is this interval increase function. Then this is point G, and from G and EF gamma sigma 0 and gamma sigma 1 convergence from EF. Then by citrus M discriminant integral 0 to infinity t at s minus 1 e at minus t dt equal gamma s as uniform convergence in sigma greater than 0. And now integral epsilon to r t at s minus 1 times e at minus t dt is holomorphic in sigma greater than 0. Then integral 0 to infinity t at s minus 1 times e at minus t dt equals gamma s is also in sigma greater than 0. I could say it's finished.